Hey guys, welcome back to Introduction to Computer Networks at NTU. This is Polly again. As usual, let's go over the announcements before we get into the technical side of the class. So this is episode 3 announcements. As you can see, bullet 1 is always the link to the live YouTube session. Bullet 2 is always the Google Meet session for the office hour for the exams and for certain quizzes. Therefore, in the future, the announcements I'll just cut to bullet 3 and on. Okay, so for this week, we have 4 assignments due. One of them is a PA, and 3 of them are the quizzes that you guys will start during the class, but feel free to try to complete them after the class. And you'll be fine as long as you get them done by Saturday, 6 p.m. For the first week's quizzes, it's okay to be late because some of you are probably still considering, or some of you are still looking to add, and you might not be able to complete the first week's quizzes by last Saturday. So those I would not count as a late submission. But that's just for the first week. Okay, from the second week and on, we'll enforce strictly the penalty policy. All right. And there's one more announcement today. This is about the PA server. You see that if you scroll up a little on the announcement channel, you will see that Poly has announced, I think last week towards Friday, end of last week, the IP address for the PA server. And that was this one. Okay, 140.112.41.221, which is very close to the IP address Polly described in the PA assignment PDF files, but not quite the same, you see. Okay, so the third number is changed. Okay, and we have to change that because Polly has been relocated over the winter break. Okay, so this is the IP address Polly used temporarily for the guys who couldn't wait to start working on the PA assignments. Okay, you see that, hey, several has said good because they are happy because they can start working on the PA ones. Okay, and I said that there are more details if you click into the PA1 channel. So if I click in here, you'll see that, guys, the team accounts are ready. And this is your account username. And the password is set temporarily to this. And you guys want to log in as soon as possible and change the password. And if you are the one changing the password, you want to make sure that you share the new password with all the teammates. All right? All right. And how do you know your team number? It's available from the Quiz 2 channel. You see that for each team, Polly has assigned a team number. If you are not quite sure what your team number is, definitely ask, all right? And so I'm using a magnet here to say, hey, attention. So I'm trying to attract your attention there. Okay, so this is the new IP address. As opposed to the PA description PDF files. It was, I think, 140.112.42 and 221. Okay, so 42 is changed to 41. Okay, so I guess that many of you probably have completed PA1. Good for you. That way you can be a bit relaxed. Okay, and allocate more time to other courses for week 2. I don't know about you guys. I feel that I work more effectively. I'm also more creative when I'm under less stress. Okay, so that's why I tend to have the habit of trying to complete the assignments or jobs before the deadline. So I'm just really tired of trying to meet the deadlines all the time. Okay, so gradually Polly has learned how to kind of how to know how much time I need for a specific job. Okay, so I guess that's something also what you guys want to learn or pick up at some point. All right. But you see, let's come back to the announcement. That IP address, 140.112.41.221, is still not the final IP address. Okay, I just talked to the network admin of the department earlier today, and I found out what is the official IP address. Okay, and I'm gonna need to change that and test it a little bit. So what I'm saying in bullet number 4 is that the PA server's IP address will need to be changed again. Okay, it's still 112.140.41 and 221, but maybe later today or tomorrow we'll need to change it to another number. But just like the announcement earlier here, yeah, I would inform every one of you. So add everyone. So maybe you wanna suppress the everyone messages on the individual channels, but for the announcement, it's better that you do not suppress this type of message, so you get the news firsthand. Okay, so what I'm trying to say in short is that later today or tomorrow we'll announce what is the final, okay, permanent IP address we'll use. All right. You don't have to redo. Good question, Sam. You don't have to redo PA1 because whatever you have done is already in the server. All I'm doing is just to change the IP address of the server. Yeah, so everything will stay the same. So Sam, no worry. But very good question, because you guys are still learning how the internet is. Therefore, you're not quite sure whether this is going to be a new machine or the same machine that you guys have already completed PA1 with, but just changing the number. Okay, so same, no worry. Or guys, if you have already completed PA1, no worry. You are still you're fine. You have already completed PA1, and your PA1 will still be in the server. All right, and let me say hi to Kenny, Kang Shuo, Yu Cheng, Mehmet, Kai Jing, Pin Yu, Yuan Hao. Okay, so if I mispronounce the name, please excuse me. Yun Ru, yeah, and Sam. All right, good. So we're done with the announcement. Now we can come back to talk about the technical things. Hey, anyone recall what we ended up talking about last week? Yeah, so last week we started talking about, we have a very, very high level overview of the internet, right? You learn that the internet has a core and has an edge. And at the edge, we have these end systems. In the core, we have what? The routers. That sounds fancy. We'll talk about these routers a lot as soon as we get into chapter 4. And those are the chapters that are super interesting. Okay, but for now, let's focus on the edge. Because I think at the end of last week, we started talking about the edge of the internet. That's chapter 1.2, right? And end systems are at the edge, and that was what I was asking in the pop-up quiz. And Yin Liang there, okay, arriving early gets to answer this question early. So, excuse me. End systems versus routers. Which kind of these are at the edge of the internet? Exactly, end systems. But there's one more thing. One more kind of device is also at the edge of the system. They are called the access nets. Okay, and there is a variety of access network technologies these days for residential access, for institutional access. Okay, so the first topic today is exactly to talk more about the access networks, and we're going to introduce 5 kinds of access network technologies. All right. And here, I would like you to pay attention to these videos, okay? And the key points I would like you guys to get is, first, for each access network, so access network is how the end systems connect to the core of the internet. And your internet experience depends on the speed of these access net technologies, okay? And the speed is actually sometimes different when it's data coming downstream from the core of the internet. Okay, and it differs from how fast data go from the end system back to the core. Okay, that is called the upstream bandwidth. Okay, coming down from the core to the end system is the downstream bandwidth. So these bandwidth, the bigger, the higher they are, the faster your internet experience is. And sometimes these downstream and upstream bandwidths are different. Okay, so pay attention to these downstream, upstream bandwidths, how high they are, and pay attention to this. That link there, or that access network you use to access the internet, can sometimes be dedicated or shared. So dedicated means that downlink bandwidth or uplink bandwidth are dedicated to you, to your home. When you are using a shared access net technology, then you might be sharing those bandwidth with a bunch of neighbors. Okay, so pay attention to the bandwidth. Pay attention to whether the bandwidth is shared or dedicated. And that starts from the first kind of access net called ADSL. So today the videos are all a little bit longer than first week. And this first video about ADSL is 5 minutes and 20 seconds. Let's see how you guys like it. The first technology is called the DSL, Digital Subscriber Line. This is pretty much a legacy technology, which is building on top of yet another almost legacy technology called the telephone network. So let me draw your attention to the example at the top. Yeah, where the telephone network is, starting from here, the phone set, okay, where you make a phone call. So the signal is going to travel through the phone wire to the hub on the wall. There are lots of also wires behind the wall, connect you through the central hub in the building and then out on the streets. And there are quite a few cables buried underground, especially for Taipei City, and those cables take the phone calls to the central office. And inside the telephone company, there are these switches. They're switching the phone calls, and eventually the phone call reaches a friend that you're calling to. So this is the telephone infrastructure, and it has been there since, I think, late 19th century. But starting, I think, late 20th centuries, we want to do this. Okay, generating emails from our home PC and send that to a friend somewhere else, okay, connected also to the internet. Now, to allow this home PC to connect to the internet, we borrow the telephone infrastructure, particularly the cables and the wires we have in the buildings under the street, so that we could send the data somehow to the central office of the data network providers here. And the way it works is this. Let's assume we're sending an email to a friend. So that email is going to go and reach the DSL modem first. So DSL is the name of the technology. Modem here is actually modulator and demodulator. Okay, the first few letters combined. So what it does is, hey, email coming from your PC is in digital form. It's going to be converted to the analog form, so it can go on this cable here and multiplex potentially with analog phone calls coming from the phone set. So these together can travel the cables and reach the central office of the service provider. And by the way, very oftentimes the telephone service provider is also an internet service provider. Now, once they reach the central office, this big box, DSLAM, it's DSL, I think access multiplexer. Okay, whatever it's called, what the functionality of this yellow box is simply, first, split the analog signals. Some of those could be analog voice for the telephone network. It will go on this way. Some of those are for the internet. It will go on the other way. And before this analog signal can go out to the edge server, DSLAM also demodulate the signal from analog back to digital so that it can travel the digital data network. You can imagine vice versa. Your friends send an email back through the edge router and reach the big yellow box, and that email gets converted to the analog form and multiplexed with the phone calls together, traveling the cable, and finally reaching the household. First, go through the splitter If it's phone call, go this way. If it's internet data, go this way. Now, at this point, the internet data is still in analog form, so modem here demodulate from analog signal to digital, and therefore you get to read your friend's response. Now, if you think a little bit more about the yellow box, what it does is essentially what the blue and the green box are doing combined. Modulating and demodulating, multiplexing and demultiplexing. What is a little bit tricky there is so that how do we do the modulation right, and how do we do the multiplexing so that the voice and the digital data will not interfere with each other. And that is done and achieved by, by splitting the frequencies of the EM carriers. So what how we are sending data or in analog or digital form is that we are modulating these signals onto the EM wave carriers. So we modulate the analog voice to this frequency band of the carriers, and upstream data to this frequency band, downstream data to this frequency band. And they are mutually exclusive, therefore they won't be interfering with each other. Okay. So phone is going through the 0 to 4K hertz frequency band, and upstream data 4K to 50K hertz, downstream data 50K hertz to 1 megahertz. So you see that the downstream data is using a wider frequency band, and so not surprising, upstream bandwidth only 1 megabits per second, and downstream we get 80 megabits per second. The last about DSL is this link here. Yeah, this is one link per household. This is very dedicated, okay, between the central office to the user. All right, so how are we doing? Yeah, I guess you can see that what ADSL is doing, right? The telephone network is there earlier. So internet actually came just maybe 30 years ago. But telephone was there since the last century, or actually almost 2 centuries ago. Okay. Now, but in order to send data, we will need to have some links there, okay, to do it. And so what ADSL is doing is to borrow these telephone wire, okay, to borrow the telephone network infrastructure. Good. And hey, are you guys paying attention to the video where I'm saying what the upstream bandwidth is, downstream bandwidth, and whether the link is dedicated? If you do, that's great. In the next video, you will see the second access net technology. Now pay attention also to the upstream, downstream bandwidth and whether it's shared or dedicated, so that you can compare cable modem as an access net technology versus the ADSL modem as the access network technology. All right, so this video, 5 minutes 44 seconds, just a little bit longer than the first one. And the second access net is cable modem. A little bit similar to DSL, it's also for residential access. And unlike DSL, which is exploiting the telephone infrastructure, cable modem there uses the cable TV infrastructure. Yeah, you see, we also have lots of wires behind the walls leading to a central office, leading to the cable company. That's how we receive the TV programs. So, cable modem here, exploit that existing infrastructure. What's nice about the cable modem is this. The bandwidth available, it's also asymmetric, where you see the downstream bandwidth and the uplink bandwidth different. In cable modem, wow, lots of downstream bandwidth, 30 megabits per second, but very limited upstream bandwidth, only 2 megabits per second. If you judge based on only the amount of downlink and uplink bandwidth from cable modem and compare it to DSL, you'll see, whoa, cable modem wins, obviously. Yeah, for DSL, this is only 8, and this is only 1. But you want to be careful, though. These cable fibers attaching household to the cable company, they are shared access links. Unlike DSL, these telephone wires are dedicated access. That is saying, oftentimes a cable company will set big cables, center cables from the center office to a neighborhood. And there's going to be a splitter that splits TV programs and across hundreds and maybe thousands of households. Yeah, if you use cable modem, sending data, your data and all your neighbors' data will be multiplexed on that cable and to the central office. That cable there is not dedicated, it's shared. So even though the bandwidth is higher, but you can, be competing potentially with all your neighbors. And it really depends on how many people are subscribing to the cable modem service in your neighborhood. That determines really the quality of your internet access. To illustrate, let me show you this example where we're connecting hundreds and thousands of households together through one major pipe to the cable company. And inside the cable company, you see often lots of these video servers, and stored on these video servers are the TV programs. So the cable head will stream these videos down this way. Gets split here, 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 here. Okay, depending on what each of the household is requesting. Okay. Occasionally also, from the household, there could be some control messages being sent, for example, to switch channels, okay? For example, to turn the TV program off. Now, if you have the cable modem installed at home, the infrastructure is going to look a little bit more extended, but most of the extensions are inside the household, as well as in the central office of the cable company. Yeah, I know, if you look at this picture here, you see, very familiar, right? Just like DSL. If there is signal coming in, the splitter here will check. If it's TV program, it will go on this way. If it's data, internet data, it will go on this way. And the cable modem will convert it to the format that's readable from our PC, and therefore you read the message from your friend. And similarly going out the other way, right? So your message will go out from the household and through the shared pipeline to the cable company. And inside the cable company, there is this big multiplexer and modulator that's doing the right thing so that your internet data goes on to the rest of the internet. Okay. And your friend sees your message. Now, be careful here. There's only one cable here. If there are messages coming from this other household or this other household, they will all get merged onto this cable. Now, these messages coming from the household, they will share the same channel and compete for the bandwidth there, unfortunately. Another thing that you might find surprisingly similar between cable and DSL is this: how we are multiplexing the original infrastructure networks data as well as internet data. And this is how cable modem is doing it. These first few channels are video, data, and last one, control. The channel towards the left, lower frequency. The channel towards right, higher frequency. So essentially what you're seeing is that the entire frequency band allowed on a cable network are divided into some subbands. Okay, so 1 to 6 are for videos, which are the TV programs. 7A, in this example, are for the internet data. And then these control messages, such as switching to a different channel to a different TV program, is only just one subband, right? And so they kind of run frequency subbands that are not overlapping, completely separated, so that they would not be interfering with each other. Okay? So that technique is formally called frequency division multiplexing. Okay? So we kind of cut the entire frequency band into non-overlapping subbands, division over frequency, hence the name. All right, now you see, using cable modem to access the internet, the upstream and downstream bandwidths are both higher. But you see also, right, in the later half of the video, given the cable network architecture, you see that that bandwidth will be shared. Okay, and it really depends on how many households are sharing the big pipeline. The sharing could be extensive. Therefore, the fraction of the bandwidth you receive for your household might be lower than what ADSL provides. Okay, so cable modem, therefore, if you compare the price, is usually cheaper. Cable modem as an internet access technology is cheaper. Now, there was a question when we were talking about ADSL. Yilun was asking, home phone doesn't need modulation, question mark. And Sam helped, since it's already an analog signal. You know what, Sam, you are right. But it gets complicated these days, how the phone is done or how we send voices over the telephone network. In the very old times, when we started using the phone as a way of human communication, yes, it's very straightforward, analog signal modulated on copper wire. But as the telephone network technology progressed, we also talk about coding the audios. And when we have coding, usually after coding, there's some sort of mixed, sort of discrete representation of the analog signal. Then you still do some level of modulation. And nowadays, some of the phones you purchase are digital phones. So the things they do in these phones can be quite complex. So the phones nowadays, many of them probably also do modulations, and the modulation can be quite complex. Okay, so you're both a good question and good answer. Okay, the telephone network is a very interesting subject of study as well. But you see that the telephone network is now kind of being absorbed by the internet. So this last mile, meaning to the access network, is now converging to this next technology called FTTH, fiber to the home. It's a different kind of cable. It's internet infrastructure in a way. ADSL is to use the telephone infrastructure. Cable modem, if you pay attention, it's to use what? The cable TV infrastructure. So when internet is rising, people thought about, hey, I want to access the internet from home. So first you thought about using the telephone network infrastructure to transmit the signals. And then you thought about using cable TV as infrastructure to transmit the signal. But none of them are perfect because they are not designed exactly for digital data transmission. Now, FTTH is. Okay, so let's hear out what FTTH is. It's close to 5 minutes, but very interesting. Fiber to the home. This is the third access net technology. Unlike the previous two, where we kind of exploit certain existing infrastructure, telephone network or cable TV network, this one here builds its own network. And because the cable are all optic fibers, so it's called an optic network. And it's essentially the internet service providers, if they want to allow users to access internet using FTTH, they will have to go out there and build these optic links into the civil infrastructure. So there are physical contact, okay, through some cables between the central office to home. And so you see in this example, it's very clean, between the central office to each household, just optic cable, optic cable. The only slight complication and boxes that are a little unfamiliar to you are these. First, optical line terminal. Optical line terminal. So this is a dummy device. What it does is just to collect signal and then convert them into digital bits. Okay, so that these internet data can go on natively through the edge router and out to the internet. Now, what's a little bit more interesting is this box, the optic splitter. We've seen this term, splitter, the third time. Yeah, at the physical level, these splitters are essentially the forwarders or the switchers. Okay, so signals gets forwarded to the right destination at this point. And signal gets multiplexed also, so that they can go on further upstream. Okay, so splitter plays the role of demultiplexing signals so that it reaches a particular household, or multiplexing signals so that it goes to the central office. So its role is a little bit like the routers or switches at the core of the internet. So optic splitter here is a very important device for the optical network. In this example, we see that there's only one level of it. In practice, there could be multiple levels, so that you could have a regional optical splitter, and then you could have another splitter here inside the building in case there are multiple households in your building, okay, also subscribing to the optical service. Now, these splitters, depending on the mechanism that's running in it, okay, depending on the design, could work differently. Okay, so two typical architecture for these splitters are these, PON and AON. So passive optical network. What it meant is that what's being done here is very straightforward. You just have mirrors so that you can reflect signals so that they go on the right direction to the destination. There's no signal amplification. But if you use active optic network splitter, yeah, these signals get splitted and amplified before they get passed on further. That is very necessary in case there are multiple levels of splitters along the way. As a signal, as it travels longer distance, even though it's optic signal, it's still decay. Okay. Now, in FTTH, yeah, the downstream or upstream bandwidth vary, but essentially the maximum capacity is much higher than the cable modem network, than the DSL network. Okay. In Taipei, very typical, you subscribe to services as downlink 100 megabits per second, uplink 40 megabits per second. Okay. If you have special need, for example, if you are hosting web servers, then you might subscribe to 100 megabits per second downlink and 100 megabits per second uplink as well. Okay, so it can be symmetric, it can also be asymmetric in terms of the bandwidth in going in different directions. So essentially much higher rates, and it really depends on how much you can afford. Right? And nowadays, these fibers can also carry telephone or television services. Okay, think about video on demand. So that is to carry TV programs through FTTH. And digital phone. Okay, IP phones are one example. The trend is going towards that's just moved to FTTH and then abandon the older legacy technology such as telephone, such as cable TV. So all content, including data, are transmitted over the one and only internet. One ring to rule them all. There you go. Yeah, FTTH is the one ring to rule the audio and the TV network previously. In a way, internet is here to rule all of the contents we had enjoyed before. All right? Great. And there was a question from Zeyu asking why the downstream upstream bandwidths are asymmetric. And you know what? Stanley answered the question. Okay, and the answer is perfect. If you go back to the videos that we talk about ADSL, yeah, we talked about that there's a uplink using a specific frequency band to modulate, and downlink uses another frequency band, and usually downlink uses the higher frequency band, and because of the physical property of electromagnetic waves, using higher frequency, somehow the reliability is higher, and the amount of bits you can modulate higher. Okay, therefore you get higher downstream bandwidth. And you know what? The user demand downstream is also higher. Okay, so such an asymmetric modulation makes perfect sense. All right, so that's why we have asymmetric modulation. And you know what? DSL stands for digital subscription line, and it's because of uplink downlink bandwidth being different. We call it the asymmetric DSL. All right. Good. I guess the three types of technologies for residential access or small corporation internet access are clear. Now we move on to the two other internet access technology, Ethernet and wireless. And Ethernet, this is generally for bigger corporation, and sometimes we use Ethernet also as part of the home network. So Ethernet, I guess if yeah, you guys know it fairly well. So this video is brief. Okay, good for us. The fourth network access technology is Ethernet. Now this is something that we're very familiar with. All we need to do is to purchase one of these Ethernet switches, connecting our computer through the Ethernet cable to it, and this guy is connected to the edge router. Then data can go out and in from the internet. Such a network access is typically used in companies and universities, okay, as they have direct access to the edge router. For households, we usually don't have access directly to the ISP's edge routers, okay? So even though you're trying to connect your end systems through Ethernet cable to a switch, but that doesn't mean your access network is that Ethernet you're using. Be careful. Now, the rate these Ethernet switch is operating goes from 10 megabits per second 10 years ago all the way to nowadays 10 gigabits per second. But I think typically people use an Ethernet switch at this speed, 1 gigabits per second. And nowadays it's actually dedicated upstream 1 gigabits per second and downstream also 1 gigabits per second. 10 gigabits per second Ethernet is a little bit limited in only those companies who are, for example, hosting a lot of data. Then they need 10 gigabits per second Ethernet, particularly video providers. All right, so Ethernet, it's symmetric. Well, the uplink, downlink bandwidths are the same, and nowadays we have 10 gig, well, at least 2.5 gig, well, at least 1 gig, right? And the scale you can see much higher, at least an order of magnitude higher than the ADSL cable and FTTH access. Now, the last kind, wireless access. Nowadays, we have a high variety of wireless access, which is very interesting. This is the last access technology. It's called the wireless access. That's just how I refer to both of these wireless access technologies in a general term. Okay. The common characteristic is that all the devices, okay, on the same channel will share access. So the way it works is this. Devices sending wireless signals. It's picked up by the wireless base station and then passed on to the edge server and then further on to the internet and vice versa. So these base stations, in the context of Wi-Fi in particular, are also called the access points. Now a little bit more about Wi-Fi. AL2.11b or G, this is actually a pretty old standard. I'm pretty sure that all of us are using AL2.11 at least N. Okay, so that's Wi-Fi generation 4 in another way. The bandwidth with Wi-Fi generation 4 is already close to 400 megabits per second. Okay. And the frequency band is no longer just 2.4 gigahertz, but also the 5 gigahertz band. Okay, that's why when you purchase a new Wi-Fi AP, you see that, hey, a lot of times when you set it up, you see two channels, one for 2.4 gigahertz, the other for the 5 gigahertz. The next major generation is Wi-Fi 6, which operates also on both 2.4 and 5 gigahertz. For backward compatibility, in case you're still running AL2.11b or G. For Wi-Fi 6, the bandwidth actually go up this high, 900 and plus megabits per second. Really nice. I think in the next generation, that's called the AL2.11ad. Yeah. For this version of Wi-Fi, it's gonna operate at this frequency band. 60 gigahertz. It's super high frequency, super high data rate. In fact, 5G is also aiming at this frequency. So bandwidth is going to be a lot higher, but you see also that the transmission is very directional, a little bit sensitive to the antenna design, okay, and very sensitive in case there's mobility. All right. Wi-Fi, interesting development there. AL2.11ad. The last one, okay, wide area wireless access actually meant, so 1 megabits per second, this is for 3G, okay. For 4G, we get slightly more than 1, sometimes go a few megabits per second. With 5G, you get easily tens of megabits per second and sometimes very close to 100, but only downlink. I have not yet seen any sort of measurements about 5G uplink bandwidth. It would be very interesting to know if you find any, okay. But although these bandwidths we're talking about, downlink, uplink, it's increasingly higher and higher even for wireless access. But be very careful. As opposed to Ethernet, as opposed to optic, wireless is, after all, shared access. So these 400, 600, 900, or close to tens of megabits per second bandwidths are shared among all the users. And nowadays, we are probably connected to the network more through wireless access network, okay, than the wired one. All right, so that was wireless access net. You know what? We get lots of questions. Guys, very interesting because sometimes when I was reporting how this course running in this all online form goes, wouldn't the students find it troublesome taking a course that's strictly online? And are the students more interactive? I kind of tell them that, no, you guys are a lot more talkative online than physically in class. You see that the live chat proves me right. Okay, so for example, Jaden was saying earlier, is downlink 100 megabits in FTTH shared or dedicated, right? So curious, and you just ask, you know what, Jaden, it's dedicated FTTH, and that's why FTTH is more expensive. Okay, so when you are back home, ask your parents how much the home access to the internet is and exactly what's the down and upstream bandwidth. And you can try to compare the other packages. For example, the packages offering ADSL still. ADSL usually nowadays really low cost. Okay, cable modem really cheap. Okay, but FTTH somewhat expensive. And I had this feeling that it's getting more expensive, maybe rising with the inflation these days, I guess. Okay, so guys, you guys can do a survey of the home internet access and find out. But I know for sure that FTTH is dedicated. And it's very configurable. So you can actually subscribe to a package that's 100 megabits downstream, also 100 megabits upstream. Because these days, many of us are working from home. For example, streamers, they do care about the upstream bandwidth. All right. And yeah, Yulun had a comment about the asymmetric modulation, asymmetric bandwidth. You think that it's mostly because of the user demand. Yeah, I agree. Makes sense. But I think it's also partly that you have this frequency band, right? One will need to be allocated the lower frequency and the other higher frequency. And it seems also natural, right? Thinking about it, considering the user demand as well. Sherman? I suppose high frequency gets more loss while transmitting. Very good question, Sherman. You guys know electromagnetic waves, right? When we transmit a higher frequency wireless wave, it's easier blocked by obstacles relative to the lower frequency band. So you lose pretty much 80-90% of the energy. Okay, you are right, Sherman. But you see that when we are transmitting electromagnetic waves over copper wires, for example, or over optical cables, for example, it's already a clear channel. Well, it's still a noisy channel, but it's a channel that we know that there's a certain media there, okay, allowing transmission of the signals. Okay, and so, usually higher frequency, higher energy, so the influence of the noise is relatively lower. So this signal to noise ratio tends to be higher. That's why when we're transmitting higher frequency, we get kind of higher throughput. Okay. I guess, Sherman, we can talk about this as you go on to take the more advanced courses about modulating wireless signal, modulating signals. Now, modulating wire signal versus wire signal are somewhat different. Okay, so Sherman, I know that there's no perfect answer for your question. It's lossier, and in some cases, not exactly lossier. And same. What does LAN stands for? Yeah, it's local area network or local access network. I guess either way is okay. It's a local subnet. Okay, so for example, NTU, EE, we are on 2 local subnets. So these machines on the same LAN are usually close nearby each other. Okay, so that's what LAN meant. There's another term, acronym called WAN, wide area network. That usually meant the bigger network that is composed by many of these LANs, smaller networks. You see, WAN, bigger internet, LAN, the small networks. Okay, and they might be connected to form bigger, wide area networks. But what happened on the internet is more that we have also many WAN, and many of these WANs are connected to each other. And then finally, we have the internet, okay, the ultimate network. All right, good. Very talkative class this semester. And we need time to go on, otherwise we won't be able to complete quiz 4 today. Do we? Oh, no, we don't. You know what, guys? Let's go on to talk about, to summarize access network. We'll then work on the quiz tomorrow. So this last video is working as a summary of all the technologies we talked about. And you will see also that in a household or in corporate settings, we might use a combination of these access net technologies to form the LAN. To sum things up, we've talked about 5 access networks: DSL, cable modem, and the very powerful FTTH, the optical network, to allow all the data, not just text-based, but audio-video data, to traverse. And it's replacing the traditional phone network, replacing the traditional cable TV network. We also talk about Ethernet access and the very, very popular wireless access. Now, all these 5 are access network technologies. These 3 definitely use a lot more for residential access. These 2 definitely use a lot more for institutional and mobile access. But nowadays, in a household, as the demand of using internet is on the rise and there are a lot more end systems are connected to the internet at home, having just one particular access network to enable multiple machines to go online at the same time is really challenging. So we have a hybrid access network in a way. In this example I'm showing, this is a very typical home setting. Cable modem here is to access to the internet for the household entirely. But after the cable modem, we have what? An Ethernet switch here, okay, which is also called a router, which also runs the firewall functionality. This guy here would allow, for example, these PCs to connect to Ethernet cable to it. Yeah, these PCs are accessing internet using Ethernet switches. And the switch here can also connect to a Wi-Fi AP, and so that these laptops are accessing Ethernet through Wi-Fi. So in just this example, you have devices accessing the internet through different access net technologies. And be a little bit careful when I ask what is the access network for a particular computer. It can be relative, right? So this guy here is through Wi-Fi, this guy here is through Ethernet. But if I ask, how is this household accessing the internet? Yeah, the access network used by the household entirely is the cable modem. Yeah, you see, the access network is relative, right? From your room to access the switch in the living room, or from the living room to access the internet. The access network technology you're using can be different, all right? And guys, you know what? That's all the time we have today. Tomorrow morning, we'll start talking about the physical media. What I meant by that is simply the links we use to connect the access net to the end system, to connect the access net to the internet core. All right. And hey, right after we started talking about cables, we'll work on quiz number 4. All right, great. And feel free to type all the other questions you have, but with that said, let me say goodbye and I see you tomorrow. Okay, bye. Bye. Yeah, so guys, keep in mind that's be curious, that's ask questions, and the rest of the class be supportive and participate. Okay? Usually the more you ask, you discuss, the more clear the things are. All right. See you tomorrow. Bye. Ha ha ha.